Okay, so this morning we will go to our discussion on the component method, component of a vector. So what our specific example that we will follow now is the example on forces. Usually that's the kind of example that we are trying to use. Okay, so again, our vector will have two components, and we have x and y component. Sometimes the x and the y components are considered as the vertical and the horizontal component. So commonly x is labeled as the horizontal line. So horizontal component will be labeled as x. Y is also called as vertical component. So this is one of the things that we will be learning. And then again, we are not limited only on two vectors and we find its resultant or resolving vectors na duwalang forces or vectors, but we could have three or more of that. And again, we can find its resultant. So the end goal here is to determine the resultant of a given vector. So the resolution of the vector or the finding of the resultant is our main task. So let's have this in mind. The resolution of a vector or a force or a resolution of a displacement. Let's tackle an illustration here. So we have here a specific example probably. So this is a car that is moving along a straight line. So probably this is the direction of the car. The car is going in that direction. So the blue line here that I just draw indicates the direction of the car. Now, however, if we will create an x and y plane for this car, so if I'll draw something like an axis for this car. So let's say this is the north-south line. And then we have here the the west and the east line. We see that with regards to the x or to the y-axis, with regards to the x or to the y-axis, we see that the car is relatively moving in two different directions with respect to the x or to the y. So may ara siya component nga pwede natin ma-consider nga ara siya sa horizontal ini amaning iya nga horizontal component bale So if these are displacements and there's also another displacement that is with regards to the y-axis Now these three lengths are always or should be always perpendicular to one another So usually we draw this foot of perpendicularity to indicate that they are 90 degrees with one another. Now that relationship that they are 90 degrees with one another gives us a knowledge nga pwede natin magamitan sa Pythagorean theorem for some reason. Okay, so but then again this is how we could think of a vector R that it has two components. So maybe x here is our we could probably call it as the horizontal component. And then our y there we could call our y as our vertical component. So again, I have that in mind that in every given vector it will always have two components. Now, if R there is a length that is provided, then therefore now we see that the relationship of our R with our x and y will probably be related to some angle that this car is making with regards to the x-axis. This angle in our trigo, we can call that as a reference angle. A reference angle is always measured from the x-axis. No? Now, with regards to some angle theta, we can actually relate the relationships of y and x with this cosine function. Like for example, cosine of theta. No? So cosine of theta, we can write that either as a function of our adjacent over our hypotenuse. No? Adjacent over hypotenuse value. No? And if you divide x by r, you can have a relationship of the cosine of theta. And your sine of theta, your sine of theta can be related as opposite over adjacent, which gives you y over r. So therefore, we can always express a value of x and y, if you will try to find that in terms of our r and our trigonometric functions cosine and sine. Now, for instance, we will try to find how much is x, assuming x and y are unknown. Supposing we do not know the values of x and we do not value the value of y. All we know is the angle with which the car is traveling with respect to x and ang length ng r. So ang r bal-an naton. So we know r, we know the angle, but we do not know the values of x and y. And again, x and y are our components. Now, in terms of cosine, sine, and then the length r, we can actually create a relation there that x can be equivalent to the product of r cosine of theta, while y is equals to r sine of theta. Again, how did we get that? So we simply multiply this, we cross multiply them. So therefore, the numerator is determined by the cross product or the cross multiplication of the denominator and the value on the left side. So we see here that our values of x and y can now be determined. So meaning x is the horizontal component, we are able to find that. Y, which is the vertical component, we can also find that relative to, again, the given vector r. So that those are two values that we can actually determine from what we just have. What's the main point there? The idea of this symbol is that at the end, we will be combining all the x components together. So if we are able to identify all the x components, we are able to identify all y components because we are dealing with two or more vectors. We have to add them together. Okay, so the symbol that is summation of x, which is indicated by that symbol, summation of x, or summation of y, is telling us that we are adding all y components and we are adding all x components together. So we will not only have one component, but we will have a lot. So therefore, we combine them and we use the Pythagorean theorem. So this symbol here below is like your Pythagorean theorem. So you'll be applying the Pythagorean theorem here once we combine all of them. Now, that one will give us the resultant, and also the tangent function of our or the angle of our final resultant is determined by getting the tangent function, and it is equals to the total components in y over the total components in x. Okay, so I think that's with regards to how we use the component method. So again, what I want you to remember is basically this one. These are very important equations, the one that I leave. Okay, so again, now here is that equation. So our vector here, the only vector that we have here is given by this hypotenuse. No? Supposing that hypotenuse is this blue line, so there would be two components that you will eventually find. No? These two components, no? AX and AY, no? Which is determined by these two given equations. And we already mentioned that one. No? Now, sometimes these vectors are drawn in quadrants 2, quadrants 3, quadrant 4. No? And they will have probably no, a varying value no, in terms of their sign. No? So, again, no, sometimes they will become positive or they will become negative, no? Depending on where they are possibly located. Okay, sige. No? So, we will have a practical example. No? So, let's have this one. No? Now, this is a good solution that you are seeing now. No? But one thing that I would also do no, is by maybe, no, first of all, is by creating a diagram no, for each of the vectors. No? So, supposing we create a diagram for each of the vectors there. No? Now, scaling may come secondary. No? It is not. It may not be that crucial anymore. No? But a drawing is also no. That's also a good way to picture out what we are doing. No? So let's have a legend here, for example. Our legend is simply to tell us know where we are. Now, the first thing that we do is to draw our vector now one after the other. No? So let's start with vector A. No? Vector A is measured no, with some number of degrees, guys. 30 degrees with the x-axis. No? So if that's with respect to the x-axis, maybe this is how we would probably think of it. No? So 30, no? Maybe a little bit longer than the other two vectors. No? And this angle is 30 degrees. No? Okay, so we call that vector as vector A. No? So that's 30 degrees from no, our x-axis. No? Now next we have 120 degrees. 120 degrees is going there. No? And somehow it's just 20 units, no? Ang iya kalabaon, no? So maybe a little bit shorter. So this B. And how do we measure the angle of B? We measure the angle of B now, go from the x-axis still, no? From here, no? Okay. So if you are going to find no, the direction of B, B is measured now 120 degrees from the positive x-axis. No? So that's the second vector. No? The first vector again is the 30 degrees. The next one is B no, at 120. No? Now the third one, in what quadrant will we find already the third vector? What quadrant will we find this? No? Yes, Merl? So we will find this now somewhere in the third quadrant. Now, the third one is 10, no? Medyo nubo pagid siya, no? Ang C. Because that's the shortest, no? That's only 10 units. Okay, so again, no? The angle measure is, no? The angle measurement there is 225, no? This angle here is equals to 225 degrees already, no? 225 na daan. Okay, follow nyo? So how did we know all these angles again? No, so if we go back to our trigo, this horizontal line to the right side is actually 0 degrees. No? And if we go in a counterclockwise direction, the one at the top is 90. This direction is 180. No? The one which we call also east or west, no, is equal to that direction west is 180. The one going south could be labeled as 270. And then when we make a complete turn, how many degrees na when we make the complete turn?
60.
We have now 360 degrees. No? So this is an angle measurement made in a counterclockwise direction. Counterclockwise direction. No? Okay, so so quadrant the quadrant for 225 degrees is already in our third quadrant. No? 120 is in the second quadrant, while 30 degrees is found in quadrant 1. No? What angles are found in quadrant 4?
70.
So it's more than, that should be more than 270. No? Because if it is 270, then it is just simply going south. No? So it's more than 270, but less than 360. No? So maybe 315. No? That's an angle in our third quadrant. No? Fourth quadrant. I'm going to draw the triangle corresponding to A. No? And let's make it blue. No? So that one, if we try to close this and form a right triangle, and closing the angle there, which is basically 30 degrees. No? So if we form a triangle now, we will now call this horizontal line here as AX. No? Again, AX is the horizontal component. No? Another component is AY. No? Now, for B, how many components will we find for B? Now, for B, guys, we will also draw two components. One that is going left. No? And again, we will form a triangle for B. No? So you'll close this like that. No? Sorry, now it's kind of twisted. So so again, now one value there is that we have BX. No? So maybe that's your BX. And the vertical one is known as your BY. No? Now, for our 225, guys, there's also another triangle that we can form here. No? So that's only 10. So that's for vector C. No? So C will have two components again. CX and your C sub Y. Now, I draw C sub X outside because I could not draw it now within. No? Okay. So again, now we identify here the components of BX, BY, CX, CY. Now, how many degrees are there now? Will we consider for the reference angle of B? Eliza, what will be the reference angle for B?
120 degrees.
120 is the angle outside, but the angle within the triangle is equal to 60, 60 degrees. How did we know that it is 60?
Half ka 120.
Okay, so if 180 is the entire angle, 180 minus 120 outside is, there's a remaining angle of 60 degrees. Now how about the angle for C? Now the triangle below. How many degrees are there? Do we have for angle C? What do you think is the reference angle for C?
45 degrees, sir.
So that's 45 degrees. Very good. And how did we know that it's 45? That's
225.
225 minus 180 naman. No? So that's how we get the reference angle there. No? So the reference angle are crucial in finding our corresponding corresponding reference. So we have here our AX now, which is A cosine theta, and AY, A sine of theta. Now, if we substitute the value, how much will be our A sub X then? No? I want you to get your calculator. No? So if A is 30 units, no? That's 30 cosine of 30 degrees. No? Okay. So A is 30 units times cosine of 30 degrees. So our A sub X, will have what value?
20.
So we determine the components of each component of A. So there are two components of A. So how do we picture out AX? Again, I will put it in a different color again. So this is your AX, guys. The length of this line, the length of this yellow line that I draw is equals to 25.98 units. Again, the value of AY is equals to 15. So if we have these two together, it will give us now our vector A. So how did we get this lengths 15 and 25.8? We use our cosine function. Okay, so that's how we use the component. So that's the first two. We still have to find for BX, and so our B, to find BX, that's 20 units, and then cosine of 120 degrees. So we get there a reference angle, but I think we can directly find the answer by using the actual angle 120 na lang. So that's BX, guys. And I think that's equals to 10. Did we get it right?
Negative 10, sir.
Yeah, that should be negative 10. Okay, so we have negative 10 for our BX. And then what about our B sub Y? Our B sub Y. So B sub Y is B, sine of theta. And that would be 20 sine of 120 degrees also. So that's how much? So we have here our BY, which is again 17.32. We get that by multiplying 20 sine of 120 degrees, because we are now on vector B. But I want you to look for the value of the components of C, CX, and C sub Y. So please determine our components there of our CX and C sub Y. Okay, now here are our values for our CX and our C sub Y. So if you get the values there, I think the values there will be both negative. So how much will our values be? Again, our two components of C. So we have, they are both negative. Now, how did we know that they are both negative? Now they are both negative because we will see that our vector here. Look at our vector. So CX is the one that goes left. So if it goes left, usually the convention, if it is going left, is that we give it a negative value. But we did not just put a sign there, but our calculator gives us really a negative answer. Now, another thing, when we have C sub Y, since C sub Y is going downward also, downward usually is also the negative Y axis. So we see that we have also a negative 7.07 value. okay, which is consistent now with the directions of the negative x and the negative y axis. So again, now if we are going to combine together all the values of x, no, so let's say we'll sum it up, we'll put them in one place, no. So what will be our values of x, no? So this is the values of x or together, no. So ax is 25.98, bx is negative 10, cx is equal to negative 7.07. Now, if you are going to get now all the values of x, so let's sum up all the values of x now. So sometimes they have this notation to indicate the combined values of x now. Okay, and we use so we have x here, no? Now, will you add up for me x, guys?
8 point.
Adding up all the values of x now, no, because we have already identified each x values. Adding them up means 25.98 minus 10 minus 7.06 leaves us with a value of 8.91. No? Now we will do the same for y. No? We will combine together all ay, by, no, and c sub y value. Our ay value is 15. Our by value is negative, oh no, sorry, no. It's positive 17.32. And our c sub y value is negative 7.07 also, no? And then again, this is the one that we are going to add together. So we will determine that, no? And therefore, now we will usually, use the notation for summation. So we have now our variable y. So the summation of y will be equal to what? We have a positive summation of x, which is 8.91, and a value of summation of y now, which is 25.25. Now, what's the purpose of finding all these total summations of values? Is that we are going to get now the final value, which we call as the resultant r. No? Where is now the resultant, therefore? No? So the resultant, if you are going to draw a different diagram, guys, no? So maybe we can see this, no? So since they are both positive values, that the resultant is actually located, no, in quadrant 1. No? It is located actually in quadrant 1. No? And therefore, no, we can have a final value by using the Pythagorean theorem now. No? So if you have all the x values together and all the y values together, then you can have a value in the first quadrant. No? So again, if we base it on our values of sum of x and sum of y, if we will draw a corresponding value that will probably picture out x, so we can draw x to be going to the right. No, it's only 8.91, but our y value is going extremely high at 25. No, so maybe it appears this way. No, so 25.25 may roughly be going upward there. And our resultant now, the final value of our resultant will be something like this. No? So if this red line indicates the resultant, then the resultant is like that. No? Now, the final direction of our angle could be thought of as like this. No? So again, now the horizontal line is 8.95, 8.91. The vertical line is 25.25. No? Now, using your Pythagorean theorem, then therefore we could solve for the resultant r. No? So if you solve for the resultant r, So since that's a right triangle, no, then therefore we can have 8.91 square plus so let me make sure now that I'll put it in parentheses. So if there's a negative sign that you will end up with, then all that you do is to square the value. Put it inside the parentheses. Then the other one is 25.25, and you put it also in squaring it. You square the value. And extract the square root. And that's how we get our resultant now. How much is our angle theta sub r? Again, theta sub r is our angle inside here. And it must be equivalent to, so theta sub r is our angle of the resultant. Then it's equals to arctangent of opposite value, which is 25.25, divided by 8.91. And we will have now an angle in degrees. So that's how many degrees?
70.
Again, getting the angle theta, that's the arctangent of the opposite side, 25.25 divided by 8.91. The angle measure is 70.56 degrees then, and that is north of east. So where is that north of east again? Because now we have here an angle that is drawn from x to the going up. So that's north of our east. So this is our theta r. This is equal to 70.56. So that's in degrees. Okay, sige. So we have these different angles. So I want you to copy this. Now again, if we apply, so this is what we call the component method, the one that we just finished. So we end up with a vector with a resultant, and we have a direction. Now again, we are going to try to imagine what if we use the graphical method, will we end up with the same result? So maybe if we will apply the graphical method, we will draw our horizontal and our vertical lines. So we start with at the origin. So we draw A, for example, and maybe now we need to use our scale there. Now let's just picture it out. The first value is 25, 30 units, going 30 degrees. So this is A. Now if we use tip to tail or graphical method, we will draw B at the tip of A. So B is around 20 units. So this is probably your 20 degrees, no, that's your 20 units at 120 degrees, no? And then lastly, you go for 45, 10. And then you go for 45 degrees, So this is B on this side. And then this is your vector C on this end. And then question, where is our resultant? Our resultant, let's say we will color it blue, will now appear like this. So that's our resultant now. So that will give us R. And somehow, if we draw that carefully or we use the proper scaling, then most likely we will still end up with the same angle of theta sub R. Okay, so scaling will be consistent, or drawing will be consistent with our component method. So we see that it is found still in quadrant number 1. Okay, so actually if we'll try to imagine it, this length here, this length is equal to actually our summation of x, no? And this one, no, is our summation of y, no? And again, the triangle there is actually, no, this portion here that we use, no, our Pythagorean theorem, no? So this is how our vectors, no, would probably look like, no? Whenever we plot already the individual calculated components, no? Kada isa ka component, no, when we calculate them, no? So when they are found left, they are indicated as negative, no? When they are found downward, they are also, no, negative, no? But when they are found on the right side and going up, they are indicated as positive values, no? So eventually, this is how we get now the sum of x, no? We add them up, the sum of y, no, and the corresponding angle, no? And that this is simply consistent with our previous answer, no? Sige, now do you understand, guys, ang aton activity?
Yes, sir.
So I think that's the only thing that I would like to discuss today, now, with you. So unless you have a question, maybe you can try this now as a drill. I can send this. Maybe you can try this one. No? I'll represent it with forces. No? Okay, so what you're looking for is the value of R. No? So you're given there, no, 3 vectors, guys, no? And then you are looking for R. So it must have magnitude and resultant, no? Ang ginapangita nato, no?